We're ready for our next talk now. So I'd like it if you would all join me in welcoming Amit Saha with Counter Gauge Upper 90, oh my.
All right. Thanks, everyone. And hello. Thanks for coming to my talk, choosing my talk over the other excellent talks that are going on. So yeah, it's called Counter Gauge Upper 90, oh my. So I'm here to share my monitoring journey into application performance monitoring and metrics. So this is where I started. Basically, I was being an ostrich, like, seeing all those dashboards and metrics. It was very overwhelming, so I pretty much looked elsewhere as long as I could. But then things started changing, and basically, just because I wasn't looking doesn't mean things were not, things are not falling apart. Like this house on fire. That blog post, by the way, is an interesting sort of a haiku. You should go check it out. So yeah, just because I wasn't looking doesn't mean things were not falling apart, and doesn't mean that we should keep things that way. So why should we monitor? Your business needs to stay running. You don't want somebody else coming and telling you that, hey, your website is down. You want to understand system application behavior. You ship out a code change. How does that impact your application performance? Or just basically do better decision making around how your applications are running, or what infrastructure they're running on. What's the impact of this new change that has gone out? So all those things. And of course, going further from the code, capacity planning, auto-scaling, as is a pretty common requirement in these days cloud-based infrastructure. How do you choose a hardware configuration for your application? Performance troubleshooting, of course, both historical as well as when you are trying to figure out what's going on with your applications. So that basically brought me to my second stage, where I'm currently learning. Still learning. The learning began about maybe a year or a bit more back. And that's where I'm today. That's what I want to share with everybody here. What I have learned and how everybody else can get started. And yeah, basically not having to be an ostrich, not having to put your head in the sand, because the problems aren't going away. So a bit about me. I'm currently working as a DevOps engineer at a Red City, Australia. We're a small peer-to-peer lending company. Recently joined there. Previously, I was working as a software engineer, so this is my first sort of full-time foray into exclusively infrastructure and operations. I'm author of this book called Doing Math with Python. It's been out since 2016. No Starch Press has a booth here, so they have a few copies. So if you're keen, definitely check it out. And have been writing for various technical magazines on different topics for the past, it's like decade or something. I'm also this creator and mentor of this project called Fedora Scientific. It's a Linux distribution which aims at scientific computing users who are either getting started with Linux or want to use Linux for their work. Definitely check it out. We just had a new release. So, right, that's about me. If you want to follow along, or in fact you should, there are lots of demos and materials I have put up there, and I will further develop on it as we go, as we find new resources. So that's a link to my GitHub repo, which is bit.ly Python monitoring. Right, so what's a metric? Basically, the most simplest way of looking at it, it's a measure a value of a quantity at a given point of time. This is an example from the Matplotlib showcase. It's like the x-axis is time, y-axis is my overall health, and the day I realized I could cook bacon, whenever I wanted, that's when the health started decreasing. So metrics are everywhere, right? We track our weight every day. We track our calories that we intake every day. So metrics are everywhere, like even beyond software. And metrics are a way of making sure that you know what's going on with something. Matric types. So most, like these are so these are the most basic types that I'll be talking about. Depending on what software you use, they may use some slightly different terminologies. Depending on what, if you're using a hosted service, they may not even expose these things like as a first-class terms. They may just call them something else. But basically, these are the different types. The most, like the first one is called a counter. And that is usually a value whose, a metric whose value always increase over time. So for example, number of views on my talk today, hopefully not hopefully, it will increase over time. Doesn't mean it may grow very slowly, but it will increase over time because that will never go down. Or the total number of requests that on your blog post. So that's an example of a counter. Graphically, it always looks like that. It's always going, x-axis is always the time because that's what your point of reference is. A gauge is a metric whose value can go up or down arbitrarily, usually with a floor and a ceiling. So you will have like a starting point and a sort of a upper limit, and it will usually fluctuate between that. Examples of a gauge is number of blog post views per day, or number of requests per second. Those are a few examples. A histogram or a timer. This again is a terminology most monitoring systems use. For example, histogram is used by Prometheus, which is a monitoring system which I'll talk about in a brief detail later on. And stats uses a concept, the terminology as timer. It's usually something which you use to track observations. So for example, latency of a request. Now, while sort of thinking about this and preparing this presentation, I was thinking, why is it different from a gauge, for example, right? Because that's roughly what it is. It's going up and down. But I think the way I thought about it and the way I think it probably makes sense is it's like the different kinds of operations you want to do on this data. You would want to, for example, do things like, what's the 95th percentile of this observation? Or you might want to do things like, plot histograms of put it into buckets. So that's how I found is one way of looking at what this metric is and why is it different, or like why did you need something different when you have a gauge. So what I'm going to do now is like a source code walkthrough. I'm not going to do any demo, but to illustrate a few things. So my example Python application here is going to be a Flask application, which is a Python framework for those who are not familiar. So what I'm going to show here is how we can calculate metrics and then sort of write it somewhere. So this is my main Python application. Hopefully it's more or less visible, but the main point here is this first line, which is, the second line, which is where I'm importing this function called setupMetrics. That's a Flask middleware. A middleware is a piece of code which will get executed. Either you can choose it to be executed before the request, after request, or at both points of the request lifecycle. And that's usually how metrics are calculated at. Like that's it, because it happens during the lifecycle of a request. So it'll be somewhere before, in the middleware. So it's usually implemented as a middleware, and that's how a basic middleware would look like. Now, so I'll start at the bottom. So this is this function. This app is a Flask app instance. If you're not familiar with Flask, try not to worry about it. It's the concept that's important here. So basically, before request is the function, which is a Flask inbuilt function, which says that I want a particular function to be called before the request has been has started being processed. And in my case, it's this function, which is start timer, which all it does is now this request is an instance it's an object which is local to this request. So it's going to be a unique object for every new request that comes in. And all I'm doing is I'm creating a new attribute called start time, and I'm assigning it to the current time in Unix timestamp. And so basically attaching it, so that it's in the context of this request. And then what I do is I have this other function which I'm registering, which is called afterRequest, and it's basically sets up this function to be called after the response has been generated, but before it has been returned. And what I am doing here is calculating how long has it been since this request came in, more or less. And the way I do it is I calculate the current time, again in Unix timestamp, and I'm just subtracting it by what I had in the start time attribute, just above that. And so this bit gives me the time in seconds. As you can see here, I'm multiplying it by 1,000 just to convert it into milliseconds because some monitoring systems. Now, there again, once you get into different monitoring systems do things differently. One of the monitoring systems expect the time to be in milliseconds, whereas the other understands seconds. So yeah, there are lots of quirks here. But here for demo, I just have got it in milliseconds for no good reason. Like it can just be in seconds. But more importantly, not more importantly, the second bit comes here, which is what do I do with this calculator? Now that I have got the response time, what do I do with it? Now, what I'm doing here is I'm basically opening this file called metrics.csv. CSV is for the comma separated value. And all I'm doing is writing this time, basically, so writing the current time, which is the time at which I'm writing the metric. And the second value that I'm writing to it is the response time of this request. And that's basically it. That basically will give us metrics that for this request. So if we make like a few hundred or 1,000 requests to it, what we'll get is a file like this. Basically having two columns. The first column is a timestamp, which is where I wrote the metric at, or corresponding to which is when the request came in, roughly. And the request latency, which is the second column here, it's in milliseconds. So, right, so that's what this demo, so what did you see? What you saw was we used Flask middleware to calculate and report metrics. Like I sort of briefly talked about, is middleware is of course limited to HTTP, but then the concept is not limited to HTTP servers. It can extend beyond that, and it does. Like for example, if you're working on RPC servers, different RPC frameworks have their own terminologies. For example, gRPC has this what they call interceptors, which is code which gets called before and after. But pretty much every framework, every language you write your application in would have some terminology or some mechanism for you to execute code before and after a request. So if you're using something else, you'd use something else to, or rather a different mechanism, for example, for the reporting and calculation, but that doesn't change. What you also saw was the CSV file I showed you, that had, I think, about 100 requests or maybe 1,000. But just looking at those numbers, it's hard to, and that's just a demo. In a production scenario, you'd obviously have a many number of requests generated, which means those individual numbers really don't mean anything. We need a way to summarize the data. And the third point, which was lacking in those metrics, was we did not have any characteristic information, which was we did not know what did that latency correspond to, which request, which HTTP endpoint was it, which HTTP method was it, or any other, which instance of the application was it from, or what the response status was. So basically, no identifying information, which becomes very useful to answer a lot of questions, which again we'll look at in a bit. So just the second point, which was we need ways to summarize the data, and that's where statistics come in. Just very basic. I think I'm going to speed up a bit. So mean is an average. It's just a plain number of sum of numbers divided a number of numbers. It's usually not a very good indicator of things, but monitoring systems do make it available. Then we have median, which is a better average, of course. Sort the numbers depending on the number of numbers. You have a formula which you can use. None of those are usually used in real life scenarios, or because they are not probably the best indicators. But then we have percentile, which is a measure which is a way to find out a number below which a certain percent numbers lie. So for example, if I were to ask for 95th percentile latency, that is a way for me to find out, every other latency is below that. Sometimes they are referred to as upper X or upper 90, for example. Quantile is another way to find number at specific position. Again, it's similar to percentile. It's just named differently. So you can see how confusing things are. There are so many terminologies to get your head around. Okay. Let's look at histograms. Again, this is different from the metric type histogram. This is like the histogram as we learned in high school, like buckets of data. Okay, it looks like I'm running really short of time. So a cumulative histogram is nothing but basically each bucket also contains data from previous buckets, so it usually climbs up like that. Okay, adding characteristics to matrix. How can you do that? So why do you need characteristics? Because we want to be able to answer questions like, what was the latency of a specific HTTP endpoint, for example? Or what was the latency for a specific instance of application if it's a specific instance that's the problem? Or what are the number of HTTP 500s for a specific endpoint? All of these are very common basic questions to ask. Examples of metric characteristics include system identifier, IP address, container ID, AWS instance ID, HTTP endpoint name, the HTTP method, HTTP response status, or RPC method name for RPC servers. So let's do a quick walkthrough of this one. So the app.py, so it's the same as demo 1 with some changes to basically here. The second function, which is a stop timer. Here, you can see that when I'm reporting this metric, I have this different other characteristics now. I have the endpoint, I have the node ID, I have the HTTP method. So just a point, like all of these demos, they have a good README. I have tried to make sure that they are easily followed. So I'm going to just skip over things. So, and then what we have is, if you just sort of go from here a bit. So with all those data, what we get is a matrix.csv file, which basically looks like this. We now have more information about each metric. We have the prefix of the application. Maybe you have different applications running. You have the node ID. You have the HTTP endpoint method and the status. OK. So we saw how we can add characteristics to matrix. We have a multi-column CSV file. So what does it look similar to? A database table or a pandas data frame? So we're going to use pandas to basically see how we can do the bit of analysis on this. So the first thing we do for pandas is we read this CSV file using this read CSV function, and that basically gives us a data frame where the timestamp, which we reported the matrix at, is the index, and then we have each metric characteristic, which is a column. So corresponds to a CSV file. And then the next step is what we can do is we can do things like grouping. So we can use the group by function, and we can basically use, show me the data, which is the latency, grouped by the node ID and the HTTP status. And the result is information like this. You certainly have information from the data that you had. We don't have to look at these individual numbers anymore, which is on this node, for HTTP status 200, the 99.999 percentile latency was this. So that's a easy way to sort of group, do slicing and dicing of the data and find out different information. Right, summary. So your application calculates the matrix in a middleware. A monitoring system stores these, which in our case was a CSV file. And then we basically query the data using a monitoring system, which in our case was pandas. But that's not free for real. I mean, that's not how you do monitoring. What you actually do monitoring, or how we do monitoring, is by using more production-ready systems. But before we integrate monitoring, what should you monitor? It really depends on what applications you're monitoring. So network servers, you would monitor request latency, queue size, if there is any queue, number of exceptions, the waiting time for a request. For consumers' latency, I really recommend the Google SRE book has a page or a chapter on 4 golden signals, which is what you should monitor applications from applications. Right. So overall, we have two sort of what should I say, strategies that we can integrate our applications with monitoring systems. Some monitoring systems are a push-based model, which is where your application pushes metrics to the system. Example is statsd. Usually it's over UDP just to minimize the failure scenarios, minimize the time taken to push the client, push the metrics. The other model is where the monitoring system scrapes your application metrics. Example is Prometheus. So I mentioned statsd and Prometheus earlier. So these are application monitoring which you will have to maintain yourself. But if you don't have that kind of bandwidth, if you don't have operations team, if you have to do everything, then you'd probably be better off using a third-party service. I haven't used any of those, but once again, what I find with third-party services is they abstract a lot of things. So it's like they have their own predefined terminologies for everything. In most cases, which is where the abstraction comes in, which may be a good thing, which sometimes may not be a good thing. But please say no to DIY monitoring system. Don't do that. statsd. So key statsd concepts, they push metrics to statsd server, metric keys of the form. So those key 1, key 2, key n are characteristics. That's what it roughly looks like. Skip this. That's how you push metrics. And that's how you do grouping and aggregation. They have different, and that's where all the complexity comes in. Like different monitoring systems have different functions. It's just way too complicated to get your head around. That's why starting from the basic ideas really helped me. And then you have Prometheus, which is where we define, our applications define like a predefined HTTP endpoint. So Prometheus scripts us rather than we sending data. Key Prometheus concepts, again, with Prometheus as well, you can add characteristics. They call it labels, different terminologies, but the ideas are the same. Metric updates, so different metrics have to be updated differently, like so grouping and aggregation, again, different way of doing it. Labels, quantile, again, they call it percentile. So percentile, they call it, or not, they don't call it, but they refer to it as quantile, which means 95 percentile becomes 0.95 quantile here. Which should you use? Native Prometheus has some gotchas. I have written about it elsewhere. Please follow those links to find out. I also recommend using the statsd exporter. It's like a hybrid between statsd and Prometheus. So you push to statsd and Prometheus scripts the statsd exporter. So summary. Basically, Matrix gives you, eyes at your system, almost very powerful, sunglasses. So you can keep an eye on your systems and basically not turn a blind eye. So if your servers need, think whatever has to happen will happen. With all this cloud-based infrastructure, it's hard to find things if they're on fire, because you don't know where they live. So Matrix gives you a good way to find out, keep an eye on. They might alert you even before the fire has started, or worst case, when the fire has started. So we should talk about them. We should, make an effort, learn as we go, maybe from first principles, which is where, all these different terminals, different monitoring systems have their own abstractions. So it all gets very confusing in the beginning. At least that's what happened to me. But it's always good to go back to the basics, learn from first principles. And once you have learned enough, we should learn to do it right. I talked a bit about mean and median not being the best indicators. That's basically where stage 3 comes in, and that's where sort of I am now, which is learn to do it right. Lots of excellent talks out there, which I have linked from the repository. If you have any feedback, questions, please let me know. I'll be very grateful. If you didn't like anything here, let me know. So again, thanks for choosing my talk over everybody, PyCon committee for the opportunity. My previous employer and team, which is where a lot of these lessons were learned. My current employer for funding my conference visit, the Sydney Python Meetup group, where I gave a little version of this, talk before, and Nick for some feedback and lending me a travel adapter because I did not get the right one this time. So yeah, thank you. If we have time, I'll take some questions, but otherwise, we can. Thanks.
If you have any questions, please come up to the mic with them. I think we have time for a couple questions. Doesn't look like there's any questions, so let's thank Amit again.
All right. Thank you.